Nice. Last time I didn't check the comments. Right now I'll do that. Alright. It's 9 p.m. at this very moment in Germany, Munich. Let's go ahead and... Oh, it's getting colorful. Let's go ahead and check day 10 because day 9 was a bit difficult. Oh, this is too long. I don't... Maybe I'm tired. Maybe that's the reason. Okay, so I'm excited to do this streaming again. It's always fun to do this stuff. And yeah, it makes me excited. Okay, let's go ahead. My wish is, this is another difficult question to ask. My wish that it's okay, it can be a bit difficult, but not too much. Hopefully. Let's go. Day 10 factory. Just across the hall, you find a large factory. Fortunately, the elves here have plenty of time to decorate. Unfortunately, it's because the factory machines are all offline. They can't figure out the initialization procedure. The elves do have the manual for the machines, but the section detailing the initialization procedure was eaten by a Shiba Inu. All that remains of the manual are some indicator light diagrams, button wiring schematics, and voltage requirements for each machine. Again, a voltage requirement. All right. Cool. For example, I don't know what that means. Is everything fine? Yeah. For example, the manual describes one machine per line. Each line contains a single indicator light diagram in square brackets, one or more button wiring schematics in parentheses, and voltage requirements in curly braces. Okay. To start the machine, its indicator lights must match those shown in the diagram, where dot means off and hash means on. The machine has the number of indicator lights shown, but its indicator lights are all initially off. Okay. So an indicator light diagram like this means that the machine has 4 indicator lights, which are initially off, and that the goal is to simultaneously configure the first light to be off. And that the goal is to simultaneously configure the first light to be off and the second light to be on. Okay, simultaneously. Okay, let's do that. You can toggle the state of indicator lights by pushing any of the listed buttons. Each button lists which indicator lights it toggles, where 0 means the first light, 1 means the second light, and so on. When you push a button, each listed indicator light either turns on if it was off or turns off if it was on. You have to push each button an integer number of times. There's no such thing as, okay? So a button wiring schematic like 0, 3, 4 means each time you push that button, the first, fourth, and fifth indicator lights would all toggle between on and off. Okay, if the indicator lights were this, pushing the button would change them to be that instead. Okay. Okay. Because none of the machines are running, the voltage requirements are irrelevant and can be safely ignored. Okay, is it for part 2? Or I don't know. You can push each button as many times as you like. However, to save on time, you will need to determine the fewest total presses required to correctly configure all indicator lights for all machines in your list. There are a few ways to correctly configure the first machine. Okay, so this is a button, the first button. This is second, third, fourth, fifth, sixth. And it's initially dot dot dot, right? And you want to achieve to this state. So you could press the first 3 buttons once each. This, this, and this. And in the end you'll have, oh yeah, that's true. So that's the solution, for example, here. You could press 1 3 ones, 2 3 ones, and 0 1 1 ones, a total of 4 presses, and this is the 5th. You could press all of the buttons except that, a total of 5 button presses. However, the 5th button presses require this too. One way to do this by pressing the last 2 buttons. Oh, 0 2, 0 1, yeah, true, once each. Okay, second machine can be configured with as few as 3 button presses. So this is the target that you like to achieve. This is the first button that will set this one up, this one up, this one up, and this one up. This is the second button which lights these two. 0 4 lights this one and this one, and then okay, you'll need to select one of these 5 buttons. You'll need to choose them, and then apparently last 3 buttons 0 4 to these 0 4 0 1 2. So basically 1 2 and 4 is open right now, and then 1 2 3 4. So 1 was open, it was turned off. 2 was open, it was turned off. This was not open, it was open now, and this is turned off. Yeah, that's right. 3 button presses, it works fine. The third machine has a total of 6 indicator lights that need to be configured correctly. Okay. The fewest presses required to correctly configure it is 2. Huh. Okay, yeah, it's a pretty interesting one, I would say. Okay, let's do. Okay, let's make it. My eyes hurt right now. Can we make it? I don't know. Yeah. Okay. Nice. Okay, this is it. So basically, you have how many? Four things, and you would like to achieve this thing. So if you basically you're choosing a combination of things. Like one option is only this one. If you use this one, this will light up, right? So this will light up. But that's not our goal, so you can move forward to this one. So if this one and this one will light up, it's not the final thing that you'd like to arrange. It goes up. So this one, now it's not enough. This thing is not enough. 0, 2 is not enough. 0, 1 is not enough. And this we can basically ignore for now. Okay, so let's remove this ignore part right now and continue on. I'd like to have, so now I'd like to have combinations. Maybe this thing, this two, it only becomes this one, right? This one lights up. This two, it's this. I think like this two was making the result. So because it first does this and then 0, 1 again. So basically this one goes away, turns off, and the number 1, basically the index 1 is also light up, and it matches with this one, so you can directly say you've done it. So basically you're calculating the combinations. Perhaps you can with the brute force approach, the most basic approach, you can calculate the combinations of these buttons, perform them, check if it matches with the end state. If it matches, then it's good, we're good. If it's not, we're not good. Would there be a better option? I don't know. Maybe from here you can say, okay, it's like consisting of 1, 2, and you'd like to arrive to some kind of version of this, but I don't know. I really don't know. My idea is just have all kinds of combinations. So it's like 3, 1, 3, 2, 2, 3, 0, 2, 0, 1. Okay, if that's done, let's move on to the items with 2 numbers. So it's like 3, 1, 3, 3, 2, 3, 2, 3, 3, 0, 0, 2, 3, 0, 1. Then 1, 3, 2. You got the gist. Once you have these combinations, you can apply them, check it out. Once you find the solution, you can just directly return, oh, okay, we have 2 elements here, so that should be the result. Okay, let's implement that, I would say. Read the size is important, right? Maybe not. Do you think size is important? Like the size of this thing. It can go like this as long as it is, I don't know, let's have the elements first and then we can construct. Like let's have the, what the question says. Indicator lights, buttons, and voltage requirements. And these are the indicator lights. Let's call them indicators. Okay, indicators, buttons, and voltages. Read input. The path is, for example, Q9 input test txt, def read input path string returns this indicators. So indicators is a string, buttons will be a list of tuples. Of course it will be a tuple right at the end. And the voltage is it's I don't know, it's a set, right? Set of integers. This was list of tuples, and tuples can have many numbers basically. Let's call them as tuple. Tuple is enough. Let's do this. Return 0, 0, 0. So okay, we seem to do a good job. So the first element is definitely the indicators, and the last element is the voltages, right? I think from there on you can identify it. So the first element is the indicators. The indicators are array 0, and what do you see when you look at them? It's a string, but you can, yeah, I don't know how to represent. How would you like to represent it? I think it can be represented as I don't know, like only representing it as 0, 1 seems enough to me, to be honest. It can be basically a tuple containing integers. Yeah. So array 0 is this thing. And I wonder, I think you do some kind of thing. Print indicators. Return 0, 0, 0. I think this kind of input modif thingy, you can do it. Yeah, array 0 is a string, actually. What are you complaining about? Oh, yeah, yeah, yeah. First part. So basically, these are the machines, right? Machines. So this is one machine, and you will have a list of them at the end. I don't know. This type int, I don't think it's a good one right now. I'm not sure. I don't feel good about it. But anyway, so for indicators, just I like to just take the first one for now, and I would like to inspect it. So now, what will happen? It doesn't. I don't know. Maybe you can actually say, once you have this machine, you can iterate over it. For this is the indicator. Indices. Let's make it a list. We're going to iterate over for character in indicators, or maybe you can do. Oh my god, I feel so tired at the moment. Wait, let's get water. Right. So we're going to fill up this machines thing, but we have to iterate over our input array right now. So this is, for example, B, this thing. And from there on, we'd like to fill up this indices. So it's like 1, 2, right? Then indicators, I don't know. yeah, something like this, and then you're going to check if indicators I equals to this hash thing. Just indicator indices append I. Okay, so that's one thing. What is the other thing? Then we'd like to buttons. We can have them from 1 to -1, and we're going to apply, I think, like map a tuple. I'm not sure. Would it work? I'm not sure whether it works, but it works. If it works, it works. So it should be fine. Okay, maybe we can check Python. Python 3. A has a tuple of this thing. Hi. Map tuple A. No. How do we do that? Python map apply. No. Okay, Python map. I think apply is coming from pandas and stuff. Okay, you map your function. I'd like to cast. Yeah, map tuple. Why do you not accept that? Project. The project is I'm trying to solve the day 10 advent of code. And trying to read the input file. Allah Allah. My brain just stopped. Okay. I'm Am I expected to do this? Do you expect me to do that? No. Thank you. I'm pretty sure that's not the correct thing, but this is what I've done here. You just type ms. I'll just give up. 1 to -1. That's the buttons, right? And then we're going to iterate. We can go over it. Buttons, tuples. no, no, no. This thing. Buttons as tuples. Append. Show me what you got. You should be fine right now. I don't know. Return none, none, none. No, it's not that. How do we do that? Like, you have this, and you like to basically turn it to 1 3 1. You just strip away the. I believe it was something like this. Oops. Okay. So am I just going to do this? Okay, go back. Okay, last thing, you don't need to. No, I think that's okay. That's okay. We're pretty good right now. At this very moment. Okay. So now you have the buttons. Now the last thing is, so this was you get the indicators. Now you get the buttons. The other thing, oh, we don't care about that. You can just, yeah, we don't care about that. So basically you're going to put this thing to machines, append this indicators. Oops. 1 second. Okay. Buttons as doubles, and let's put none here, and then you're going to return this here. Machines, and print the machines. Let's go. Good. One thing I want to put indicator indices there. 2 3. Yeah, you're right. It has to. You have to put -1 there, because now look, this is the indicator lights are open in 1 2, right? Here it's at 3, and this is 1 2 3 5. Good. Okay, so very good. We've read the input. It's the most ugly method that I ever written. Just forget about the typing. I'm just ashamed by it. Let's delete it. Okay. Nice. Once you have that, now you'll basically, yeah, for machines you can say indicators and buttons and the other thing. From now on, you'll do the following. One solution. Button combinations. Get button combinations. You can call them, yeah, button combination. Okay, it's okay. And you're going to give the buttons. And then check combinations. You're going to put the button combinations and you'll try to arrive to the state defined in the indicators. The thing here is you're not considering the multiple usages of these buttons. I think you can also put them into the combinations part. Does it make sense to use them twice? 3 times? Maybe. Yeah, maybe. You're going to check the combinations. Or like is if it's successful or like or is matching, you can call check combinations, check combination. You're going to have the combination and you're going to have the indicators to the final result. If it's matching, you can say return basically yeah, and combinations append len combination, the length of it, how many buttons that you clicked basically. Good. Good. If it's not, no. But at the end, you like to break it and you move on to the next machine. You get the indicators, buttons, you calculate the button combinations again. For each combination, you go, they're like in the ascending order, okay? Ascending order with respect to length of the button, with respect to button presses. Count, I don't know, something like that. You check the combination, if it's matching with the indicators, you do it, otherwise you'll just continue, and hopefully you'll match something, and in the end you're going to, I think you're going to, is it like sum or something like that? You're going to sum them up. We can calculate later on. Let's for now print n combinations. Let's fill up these methods. Def get button combinations. You're given it's basically it can be combinations. You're giving an any array, list of any, and you're going to return list of Yeah, why not? You can do it list of any as well. There has to be a method for it in Python. Combinations something, but yeah, we can have a look. And the other one will be check combinations. Maybe I can use Python built-in combinations, start from one element to more. I don't know. Let's see if it will understand or not. Okay, anyways, I think it's also defeating the purpose of this practice. I won't do that. So combination button combinations. So it's accepting the combination, and the indicators is the final state. It's also a list of integers. Combinations actually is a specific type. It's a list of integers. No, not necessarily. It can be. Anyways. Oh my god. Let's do the following. I think it's okay for us. Permutations. From itr tools, import permutations. Permutations, array, and elements, number of elements. And you're going to say for elements in range, then array. Combinations. Append return combinations. Can we, let's see, so get combinations, it's called here. Let's tell me, let's print it out. It's returning, I don't know, true. No. combinations. Append combination. Wait, what? I think I'm just going to stop today. Yeah, it's not possible. It's not coming out. I feel very tired. Maybe it's time to call the end of today. See you tomorrow. Happens.